Autodesk webinar series organized by Trident Corporation. There will be 3 more webinars in next month. So this is the final webinar we have scheduled for this month. Our today resource person is Mr. Tandavan Bhubalan, Autodesk technical specialist for Autodesk. Mrs. Andavan carries 8 years experience in training and technical support on Autodesk softwares, and specialize in mostly AEC and manufacturing products. So he will carry out for the our today topic, digital prototyping, based on Autodesk Inventor software. So we'll go through his slides, and we'll have after that the question session. Tandavan, over to you.
Yeah, thanks, Janaba. Hi everyone, good morning. So welcome. First of all, thank you for joining us for the presentation and for the Autodesk Inventor presentation today. And today we are going to discuss the tools that design. Today we are going to discuss the tools that engineers and designers have trusted worldwide, and the tools that deliver the technology, and that you need to take your ideas from concept to the manufacturing. So any kind of a design you start, so the first thing is like to start with the conceptual design. So the Autodesk Inventor, which will help you to start your designs from scratch, which is from the concept to the manufacturing. So we can see the overall process. And today I'm going to concentrate more on Inventor. And there are many features which I can talk about Inventor. Okay, in one single product, there are multiple modules and multiple features are involved here, and which can help for the engineers and the designer. So we'll look into those. So before getting into the product, like we have some questions here, right? Like how we can spend time to be more innovative, because instead of spending a lot of time in doing repetitive tasks, and we need to come up with kind of an innovative design ideas, because we often hear from our customers and they are looking for ways to innovate. And however, right now they are struggling to find the time to spend a lot of time in creating a new things, right? And our customers and consumers are looking for a better performance, which requires a complete understanding of how your design operates before it goes for a build. Before we go into a see right now, like where we go and create a model, I mean, like we manufacture the product and we do some physical testing on it. Then we identify like what kind of a error it's coming up, whether it can withstand the weight or not. There are many companies still they are doing it. It's a kind of a traditional process. So before we build it, so we wanted to make sure like whether my my part or my manufactured the element which will perform properly or not. So what would be the performance of the model, or what is the material optimization I can do, and what kind of an innovation designs I can bring in on that, and how I can connect it to the Streamline Manufacturing, and so that only then we can able to win more business. But the reason is like right now we have multiple competitors, so we need to spend time and when we have a multiple competitors, we need to deliver our design faster to the market as soon as possible. We need to create new concepts, the better performance of model, and then we have to deliver the model to the market, right? So only then we can able to win more business here. So let's address those things, and we might be having a lot of questions right now, and let's see one by one. And before getting into this product, so first of all, we'll see what is Inventor. So many of you might be new to Inventor, or many of you are already using AutoCAD, okay, and still looking at a solution to move from 2D to 3D platform. Okay, let's see what is Autodesk Inventor. And I would say it is a professional grade design and engineering software, and it is a complete design solution for design to manufacturing, as I mentioned. So it automates design workflows as well as everyday repetitive tasks, and it connects your process from concept to make, and it promotes collaboration among teams and your customers. In the next few slides, we will discuss these 3 pillars, which is complete, automate, and how you can connect with the internally or as well as to the other stakeholders or to the manufacturers, and we'll take a deeper dive into throughout our presentation, I'll explain like what kind of a features which will help you to do this complete design, starting from concept to the manufacturing, and how you can do some automations within your model instead of creating multiple part elements or multiple assemblies, and how you can automate something. Okay, design automation to reduce your repetitive design task. What are the features are involved in that? And let's see, like we'll explore a few other areas like how you can collaborate your design. That is most important, because it's in a project there are multiple team members and you have to collaborate with and you need to collaborate or you need to connect with the stakeholders or to the manufacturing team, right? So there are a lot of coordinations are involved. Okay, so if any last minute changes comes in, like how it can be communicated back to the design team. Okay, and right now if you are using AutoCAD, there are a lot of effort needs to be there, because you have to produce multiple views, right? Like front views.
Assalamualaikum.
Yes. I request Jendrika if you can mute everyone.
Ennathun ചെയ്യുക? Melangalla.
Dinaka, if you can mute everyone. So we'll see some options around connected options, like how you can collaborate your designs to the stakeholders. And Dinaka, you're there?
Nusrat and the body and
Yeah, I believe you can see my screen now. So we'll discuss about these three pillars, which is complete, automate, and connected, and let's look into those. So when I talk about the complete design solution, so in Inventor it comes with like more powerful 3D modeling, and you have a tools to validate your design, to analyze kind of a stress analysis or a dynamic or model analysis, and you can do some kind of an integrate your AutoCAD drawings also. Like even if you create some 3D model, 3D part designs in Inventor, if you'd like to do some shop drawings or create some documentation, you can take your Inventor part family, part model to AutoCAD user interface, and you can do some. You can create front view, orthograph views, and sections, and all this, and you can submit. If some of your consultant or some of your client are using AutoCAD and you want to still you want to submit some AutoCAD drawing, Inventor supports all type of an AutoCAD integration, and you need more time than a greater CAD modeling software, and you need a complete solution that is going to see your ideas all the way to the manufacturing, and a solution that includes a powerful and flexible 3D modeling capabilities to design anything. Okay, and as I mentioned, like design validation tool to ensure your concept and designs. Okay, and we can make sure like how it works or how it performs, and the complete tools you need to effectively communicate, which helps you to effectively communicate with the manufacturing team as well. And when I talk about this automation here, so automation is a key, I would say, is to save time for more innovation. It is used in several areas like rapid reconfiguration of your design, for customization and design reuse. And also you can say specialized design tools for sheet metal, frame design, mold tools, and more. And you can access to a massive set of library of commonly used components, and also system settings that can adapt to the size and complexity of your design as you work on. So the connected one. So when we mention about connected, it's not only about the collaboration. So I would say Inventor is completely connected platform, and we know that the success of any given project spans beyond the 3D modeling. It also about effective collaboration inside and outside the four walls of your organization, managing your intellectual property in a way that satisfies your company's requirement and working associatively with other CAD system. It's obviously it's going to save time and reduce lot of errors and rework. And this is the kind of challenges that currently engineers have been facing. So this platform will really help you to do all kind of an effective collaboration. You can share the views and you can integrate any CAD functionalities also, which I'm going to discuss in a further slide. Let's take a deeper dive into what makes Inventor a complete design solution. So what are the other features are involved, or what are the other modules are within Inventor? The first thing is part modeling. Okay, so Autodesk Inventor enables you as a designer or engineer to focus on your design first. So spend more time innovating and less time looking for a tools you need to accomplish your engineering task. And there are those tools are really flexible modeling tools to suit your needs. And when we speak about flexible modeling in Inventor, there are three methods are involved here. So each of them, like I would say parametric, direct method and freeform method, and each of them is like distinct, but they all work together to efficiently enable you to design anything. Okay, so even when you look at your image, like you have different types of parts which can be used. What are the designs we do? It's completely a parametric, so you can add your formulas, you can add your expressions. Okay, so and with that parameter you can derive your automation also, that I'm going to discuss in the further slides. So when we mentioned about this parametric modeling, okay, like starting with parametric modeling, like you are building an intelligence to your design and apply the proper design intent. So when changes happen, your design will behave exactly as expected. Later, we will also discuss the downstream application for parametrics in your design automation. For rapidly, you can configure your parts and your sub assemblies and large assemblies. Okay. You can see this video, like how the part modeling can be done with an Inventor.
Thunder, can't hear the voice.
Yes.
Yeah, you
You couldn't hear the sound?
No,
Can you hear the sound now?
Your most creative work happens when you're
Yes,
free
yes.
from distractions, completely immersed in the flow of design. That's what it's like to design with Autodesk Inventor. Inventor eliminates the interruptions that prevent you from making progress. Geometry can be created the way you think without having to devise workarounds. The commands you need show up right at your cursor, right when you need them. And you can easily make changes without having to hunt for the right feature or fight with existing geometry or constraints. Quickly move from 2D sketches to 3D geometry and leverage existing features to make intelligent symmetrical models. When sketching, the ribbon contains the entire set of sketch tools, but you'll find you rarely need to take a trip up there. The marking menu, accessed using the right mouse button, contains the most commonly used commands and keeps you focused on the design rather than the interface. Creating 3D features such as holes is intuitive and as easy as selecting on a surface. And because our model is parametric, this means you can easily edit your parameters and see the results in real time. Additionally, while sketching, you can add geometric constraints that act as rules for how geometry behaves and limits the number of dimensions required. When building features such as fillets and chamfers, simply select the edges of a part and then pick the command you want. And you can again drag using a handle to adjust the size visually or key in the exact dimension. And the parent-child relationship dialog box shows you all the dependencies of an object you've selected, so you know the upstream and downstream impact of a change before you make it. By nature, the design process is iterative. Changes are inevitable, and you should be able to make them as easily as adding a new feature. Rather than stopping your progress to hunt through the history with Inventor, you simply select what you want to change in the model itself and an icon pops up, and it'll take you directly to the feature definition or the underlying sketch. Our goal with Autodesk Inventor is to deliver a tool that lets you focus entirely on designing great products rather than the software. It's robust, so you can model what you want, how you want, regardless of the complexity. And it's easy to use, so every command becomes second nature. Creating geometry and making changes are simple, so you don't have to take a step backwards to move forward with your design.
Yeah, so this is about the parametric modeling. You have seen that how easily you can add your expression on this. And let's see that freeform modeling, like when working with products that have complex and organic shapes, right? So the traditional approach of using like splines, features, or sketch and surfaces, usually it results in you spending so as much time and effort focusing on how to model as you do on what we are modeling and what you are modeling. And the concept stage of the design process should be fluid, like, and the limits of your design tool should never force you to make compromise to a shape and quality of your product. And freeform modeling enables you to create visually a compelling and complex organic shape with less work and less time than the traditional way of 3D modeling tools. Like it comes with a default, like organic, you can create some complex and organic shapes, like wherever the 3D area you want to pull in, you can just easily, you can do that. So the other one is like your assembly modeling, so which is the most important one. Like whenever we working on a part modeling, so we need to create a sub assemblies as well as the large assemblies. And Autodesk Inventor ensures the fit, form, and functions of your complete assemblies before anything gets put together in one location. And quickly, you can easily place your components and simulate the motion of the part elements, or by using some dynamic simulations. Okay, there are some other features which is involved, which is there in the assembly area. You can use those features to stimulate the motion and identify any interferences or collision virtually. Okay, so because where the way we do a design, there are chances to have some collisions and kind of a clashes, right? So you can review those during your assembling your model also. And let's take a look into this assembly.
The culmination of your design work comes at the assembly level. It's here that you can assess fit and function, identify interferences, and then use the model downstream to create renderings, simulate how your products will perform, develop documentation, and plan manufacturing processes. But first, you need to put it all together. Just like in the part modeling environment, a marking menu is available that contains a complete list of your most commonly used assembly commands right at your cursor, such as placing components and adding constraints. Once a component is placed, assembling parts together is done the same way you would do it in the real world. Using joints, you can fully define the location and motion between two components in a single step, rather than specifying constraints one by one. Joint types are determined automatically based on the geometry you select, and all degrees of freedom are accounted for once the command is executed. Relationships can be added using traditional constraints, which gives you a finer level of control over how the assembly behaves. Adding limits to your constraints specifies exactly how much a component can move, so you can perform motion studies to evaluate how mechanisms will operate in relationship to other parts in the assembly. Because it's rare that an entire product is comprised of parts or subassemblies that are designed in-house, Autodesk Inventor supports opening and inserting third-party models directly into your assemblies. These can be constrained the exact same way you would native Inventor models, and they can even be patterned if multiple instances of the component are needed. And because there's an associative link to the original file, if that file changes, it will be automatically updated inside the assembly without having to go back and reapply all of your constraints. One final source of parts is the Content Center, a built-in library containing over 750,000 parts covering 18 international standards. Many components of the Content Center have intelligent mates built in, and constraints are automatically created when you drop them into the design. They can also be resized dynamically in the window. Existing patterns will be followed, so components are created automatically at each appropriate location. Regardless of where your components come from or the approach you take to define the relationships between them, Autodesk Inventor gives you the tools you need to put it all together in a perfect and complete model of your product.
Yeah. So after looking at all these large assemblies, okay, you would have seen that video where the large assembly and how you can do some motion study and all this during while assembling the parts, right? So one question maybe it comes into your mind is like the performance, how it can, whether the inventor can able to handle the large assembly. So that is the most important thing, like on the performance side, right? So since you guys are working on like multiple projects, so you might be having a lot of issues around the performance. So Inventor, not a problem here. The reason is like Inventor reduce the load times. Even though if you have a complete large assembly also, it will reduce that load time, and you can use better use of your computer resources, and it has faster graphics, and so that it will be easy for you to create your parts, assemblies and drawings. Another thing around is like since we're talking about the performance, the other area is on Content Center. So the Content Center is nothing but like the Autodesk Content Center enables you to generate over 750,000 standard components, starting from your fasteners to shaft components, or from rooted system to structural steel. The libraries over those libraries which covers 18 international standard components, including standards like ISO, ANSI and DIN. Okay, so these are the standards by default included, and in addition to these standard components, you can also publish your own parts and manage them, right? So the Content Center supports Inventor's design accelerator as a collection of rule-based design tools that helps and allows you to quickly generate components around your functional requirements, like adding fasteners or design a frame, power transmission or spring system, which directly from Content Center components. So you no need to spend huge time or a lot of time in designing those such components. So by default, Inventor comes with all the standard library, as I mentioned, like standards like ISO, ANSI and DIN standard. So you can just go and pick and place it. Okay, you might be using a lot of different types of fastener, right? Even fasteners are standard in the industry and standard in the market. So even if you look at the image, a dialog box image on the screen, you can see all type of countersunk, X head and round head. Okay, there are different types of studs and everything is available. You get just go there and pick which standard you want and what is the size is required. Okay, you can just place it. Okay, no need to spend time in designing all these components. And even there are some other frame generators also available, which I'll be discussing it later. Let's have a quick look on how you can use those content center in your part file.
You don't want to spend time modeling standard components like nuts and bolts, and you don't have to. The Autodesk Inventor Content Center allows you to generate over 750,000 standard components, from fasteners to shaft components and from rooted systems to structural steel. The Content Center libraries cover 18 international standards, including ISO, ANSI and DIN. In addition to the standard components included, you can also publish your own parts and manage them with Content Center. Let's see Content Center in action. In this example, parts are inserted directly from Content Center. Notice how the parts automatically size themselves to suit the features selected. Once inserted, Content Center parts can be resized or redefined from the library and contain all the information needed to automatically populate your bill of materials. Content Center supports Inventor's design accelerators, a collection of rule-based design tools that allow you to quickly generate components around your functional requirements. Add fasteners, design a frame, power transmission or spring system directly from Content Center components. No need to model any parts yourself. In the Inventor Rooted Systems environment, Content Center provides components for your piping runs and cable harnesses. Design mechanical systems, which include flexible or rigid piping routes, using your existing geometry as a reference. Content Center supplies hoses, pipes, tubes, and industry standard pipe fittings such as flanges and couplers. Design electromechanical systems, which are linked to your AutoCAD electrical schematics. Populate your design using the AutoCAD electrical data and Content Center's linked library of components. You want to spend your time engineering and designing, not modeling. Autodesk Inventor's Content Center libraries save you time and effort. Reduce modeling time, increase standardization, and make use of Inventor's design accelerators with Autodesk Inventor Content Center.
So this is how very quickly you can start using your Content Center. So you would have seen like no need to sit and create some additional parts for your designs, that you can do it. And moreover, you can use some simulation which is inbuilt with Inventor Professional, where you can study, you can do some study on your model like linear static analysis, frequency, dynamic assembly motion, and parametric design optimization. And you can also gain valuable motion results in your assembly with adding some kinematic and dynamic studies over that. And you can specify the ranges for the dimension you design and choose the size that performs the best and reduce your material cost. That is very important thing. So what are the parts we are creating, right, and we provide a proper material edit. So the ultimate goal is to reduce the material cost and still to withstand the proper strength of the, without losing the strength and strength of the element. Okay, that is because it's not the point is not to just reduce the material. We need to maintain the strength of the part and assembly also, right? So before you go on manufacture, so you can use all this kind of an analysis to get those results, and which helps you to perform and optimize your designs as well as to reduce your material cost. So obviously, once you start reducing your material cost, so you can see the profit margins in your project also, right? Another thing is on the 2D drawings, okay, which is used for the manufacturing and creating your shop drawings and orthographic views. So and you can, once you made a great design, so you shouldn't let the documentation slow you down, because Autodesk Inventor helps you to quickly get the information you need to manufacturing, and you will find a complete set of tools for clear communication to the shop floor, include the model-based definition from the model, and Inventor uses the proper native DWG file format for seamless interoperability with the AutoCAD. Like because like many of our clients or even to the manufacturing unit, they might be having a simple AutoCAD, a plain AutoCAD software. So if you want to communicate with the manufacturing unit and you want to give the AutoCAD native file format, so yes, in Inventor itself you can create AutoCAD sheets with all the views, part list, whole table list, and BOM, and all of this information can be placed on your sheet, and you can send it to a manufacturing unit. Yes, that's the interoperability we have. And more or less, we do have this model-based definition while creating your shop drawing. The other important thing is like adding your GD&T symbols and tolerance advisor, and so because there is a growing demand for engineering organization to get the design data to the manufacturing in a more efficient way, right? So Inventor provides model-based definition for including all necessary fabrication instruction directly to the 3D model, and obviously this helps and reduce the need for a traditional 2D drawing used by the CNC programmers for adding some tolerance and surface finish on top of the design. So it comes with all the default options. You can start adding all this kind of a model-based definition as well as your GD&T symbols here. Another thing is around the presentation, right? So presentation is more important, like the way how you're going to present it, and also how to create this assembled and dismantled view, and finally to create some PDF outputs. Also you can create some videos and you can play some cameras, okay, which gives like more immersive visualization. And if you are creating a manuals or a technical publications of your products, and Inventor has all the complete tools, you need to create visually a compelling content without having to invest in a separate software solution. The reason I'm mentioning this point is like people spend to create a rendering or to create a animation sequence or a presentation sequence, so they spend a separate cost from the project in a different software and they do it. But within Inventor, you can do all this kind of renderings and creating an assembled and dismantled view and produce them kind of a visually compiling content, right? So we can do that. And let's look at the features involved for the automation. Okay, so as we mentioned about to reduce the repetitive design tasks. So what is the level of design automation can be done here? So the first thing on which we can discuss about the sheet metal part. So the sheet metal environment inside of Autodesk Inventor and enables you to build component with the material and fabrication process in mind. So even if your design or controlled by industry standard, like for when the moment we talk about the sheet metal, the first thing is like the bend allowance, right? So we need to make sure whether we have a proper standard bend allowance can be created, corner reliefs, and more to ensure the flattened model and it should accurately represent the finished product level. And flat patterns are generated with a simple click in Inventor, and you can export those and them in a multiple formats for downstream use. And sheet metal tools inside of Autodesk Inventor enable you to quickly create sheet metal parts that are designed to a specific fabrication standards, and helping to make sure parts not only fit but perform as expected. Just we'll have a quick look how the sheet metal design can be created and what are the tools available here.
The sheet metal environment inside of Autodesk Inventor allows you to build components with the material and fabrication process in mind. Your sheet metal designs are controlled by industry standards for bend allowance, corner reliefs, and more to ensure the flattened model accurately represents the finished product. The sheet metal environment has its own tool palette for creating sheet metal features and modifying sheet metal geometry. Tools such as flange, hem, and bend allow you to create geometry without the need to create a 2D sketch. Sheet metal corners can be created with the fabrication method in mind, whether you need a simple square relief or one created for laser welding. The punch tool helps create commonly used features from a library. You can also create your own custom punch tools to speed up the design process. Sheet metal also allows for patterning and mirroring. This helps not only create parts faster, but also makes them more flexible. And when you need to create more complex components, such as a transition, the lofted flange command is specifically designed to transition between two sketches and supports multiple output options for proper fabrication. Sheet metal flat patterns are generated with a simple click, and you can export those flat patterns in multiple formats for downstream use. Sheet metal tools inside of Autodesk Inventor allow you to quickly create sheet metal parts that are designed to specific fabrication standards, helping make sure your parts not only fit, but perform as expected.
So the other area is to see the frame designs. Even before I mentioned, like there's a default content library. So even it has some specialized frame designs with proper sections, which can be just pick and place it. Okay, once you have a 3D sketch, you can start placing all your frame design. It's really easy for you to create that. Even in many the assemblies you create, right? You need some there's frame designs to mount your assemblies, right? And if you want to do that, if you want to create such designs, you can do it. And even to those frame design, if you'd like to provide some analysis, so whether the frame can withstand the weight of your large assembly or not, okay, a kind of a stress analysis or a frame analysis, model analysis. So all type of different analysis can be studied on that frame. And the nature of the structural frame design with the standard frame profiles and corner treatments, okay, which makes a relatively a simple tedious modeling task. And also like Autodesk Inventor makes frame designs in a very simple with a very, the user interface also is very simple. If you go to the assembly area, assembly module, you can see the frame generator option. If you have a simple 3D sketch, you can start placing your sections. Like if you want a C section or I section, okay, what type of one section you want, you can just start placing it. Okay, and on the same tab, you can find the analyzing also, which helps you to study your frame model.
The nature of structural frame design with standard frame profiles and corner treatments makes a relatively simple yet tedious modeling task that's perfect for automation. Autodesk Inventor makes frame design simple with tools specifically created to make inserting frame members, applying end treatments, and analyzing the performance of frames fast. Let's take a look. Starting with parametric skeleton geometry for the frame, you can begin inserting frame members by specifying the family, size, and material from a library containing thousands of standard profiles. Inventor gives you complete control over the placement of each member. Pick sketches, edges, or points to position your frame members, with options to offset or rotate the frame member profile relative to the geometry selected. Once the size and placement of the frame members are determined, the frame members are inserted into the assembly and automatically numbered based on your preferred file name and part numbering scheme. As you add more frame members into the design, corner treatments can be used to trim, miter, or create notches between members, and end caps can be inserted from the content center to terminate free ends. The standardized nature of frame design also makes it easy to set up and perform structural analysis to make sure your design performs as required. Just add your constraints, for example where the frame is fixed to the floor, and you can start specifying where the loads will be applied. Loads could be applied as point forces, axial moments, or continuous loads across the length of the frame members. The solve time for frame analysis is super quick, so you can immediately begin reviewing displacement and stress results to determine if further design refinement is required. With automated commands for designing structural frames and a simple to use analysis environment to make sure your designs will perform to the requirements, Inventor gives you the professional grade tools you need to get the frame design done fast.
So this is the easiest method. Like once you have a 3D sketch, you can start creating the frame design. It will become very easy for you. And also apart from these other features, like since we are I've been discussing a lot, we have other features like tube and piping also. If you would have some, if you would like to create a assembly environment with which includes tube and pipe, okay. So Inventor adds the complete design tools to create the routing of your ridged pipes, bent pipe, and flexible host, okay, to your mechanical assembly or your product design. Okay, this is also one of the feature available within Inventor. And the other thing is around electric wire and harness. Like if you have because every assembly requires some electrical wiring, right? And you don't need to go for another different solution to all this do all this wire routing. What you can do is you can use Inventor itself with the same environment. You can go for cable and harness module, and you can start placing your wire. And if you are very keen on electrical design, and if you want to do a proper schematic and wire circuit, you can use AutoCAD Electrical to do that. And if you have a complete wire routing is done in AutoCAD Electrical, you can import that AutoCAD Electrical schematic into your Inventor directly. Okay, it supports that. I told you, right, there is an AutoCAD interoperability, so you can link that into Inventor and automatically it plays the because you would have already assigned some pin assignments in the electrical circuit, right? So based on that, it takes all the data, in Inventor, you can see the 3D routing. Okay, so it provides a proper 3D routing. So that's the kind of an interoperability and seamless of integration between AutoCAD electrical as well as with Inventor. Okay, it's the idea is to no need to look for another solution to do all this electrical and tube and piping work. So within Inventor, you can do this, and also we have a features which can be within the part design. We have a plastic design is also available, so you can create your plastic part models, and you can assemble it, and you can use a multi-body approach in order to maintain the associativity between each component in your design, and without the need to create a complex top-down relationship between parts in an assembly environment. And you can ensure products that can be made using the built-in analysis tools that, like, if you like, for example, if you would like to do some analysis also, you can do it within the same interface. And other areas around the tooling designs, like which is the mold design, right? So mold design provides the integrated functionality within Autodesk Inventor, and you can use the intelligent tools and catalogs. You can quickly create a model, and you can do a accurate test on your mold design. So it has industry standard parts. You can create your core and cavity workflows. You can do mold simulations and more layout tools. It's also available, right? So these are the additional features within Inventor. And shape generator. This is a very important tool. Okay, it's a very simple tool. The idea is to optimize your designs. Okay, to reduce the in the previous slide I was discussing about reducing the material cost, right? So the same way you can use the shape generator to reduce your material cost. Okay, so it will show the like which area the material is which is not required. So it will optimize the part element and it will give you a result. Okay, so the idea is to save the material cost. You can just have a look at like how the shape generator works.
With more time, you can explore more concepts up front or develop additional iterations to improve product performance. This is where shape generation technology inside of Autodesk Inventor can help. Shape Generator works right inside of Inventor with your designs and optimizes the geometry to help you create structurally efficient components. To set up the model for Shape Generator, you simply need to define the physical properties and describe the real-world conditions the part will be under while in use. Material properties are automatically carried over from your model. Then, you just need to apply the constraints and loads to simulate those real-world conditions. You also have control over how the shape will be generated. Areas of your design can be excluded from the optimization by using dynamically sized bounding areas. Symmetry can also be defined so that the generated geometry is mirrored across one or more selected planes. You can also define the minimum member size to make sure parts don't get too thin and match up better to your manufacturing process. Once the optimized shape is generated, you can then promote the mesh back into the modeling environment to use as a template. Using the outline of the mesh, you can quickly develop sketches and cut away material to develop your final design. You can also validate the performance of the design with the full stress or modal analysis inside of Autodesk Inventor. Using Shape Generator, you can create and evaluate high-performing design options in minutes rather than days, so you can explore more possibilities and get to the right design fast. Need to do design exploration from the ground up? Subscribers to the Product Design and Manufacturing Collection have access to generative design with Fusion 360. Generative design technology allows you to simultaneously generate multiple CAD-ready solutions based on the manufacturing and performance requirements. Check it out as part of the Product Design and Manufacturing Collection.
So this is the way you can utilize your shape generator in a proper way. Another main important thing is on using iLogic. I don't know if some of you are already using Inventor, and if you haven't tried using iLogic, I would suggest you to try iLogic, which is a rule-based design. And you can avoid all your repetitive design tasks, like you might be having a different multiple size of your parts or multiple parameters need to be included in one part. You can do this iLogic, okay? And so the idea is to reduce your repetitive work. Okay, no need to create multiple items or multiple assemblies here. Okay, and it will help you to automate your designs.
Your value is not simply your ability to create 3D models or 2D documentation. You add value to your company by considering the efficiency of your design. Can I meet my client's brief with fewer components, with less machining? Could I make more efficient use of our stock materials? Design automation is the ability to automate tedious everyday tasks so that you can focus on where you add value most. Autodesk Inventor iLogic enables design automation with simple rule-based configuration built on the existing intelligence of your model. iLogic is a programming language for non-programmers. Capture your design intent by selecting which parameters, rules, or iProperties you want to make available, and drag and drop them onto your form. No programming required. Additionally, add text and pictures to your form to help communicate your design intent to your wider team. Save time on quotations or new product introduction by using iLogic to automate the configuration of your designs. Increase quality by using iLogic to standardize your procedures. Prevent errors by building error checking directly into your model. Your rules can be stored directly in the document, making it easy to copy your automation as you copy your design. Focus your attention on value-add activities by automating your repetitive administration tasks. Invest in design automation to standardize your procedures, eliminate repetitive tasks, and focus your time on where you can make the most impact with Autodesk Inventor's iLogic functionality.
That is the advantage of using iLogic, and even previously I showed you some in videos also you would have seen the design accelerator. Like by default it comes with all shafts and spur gears and bearings and cams and roller chains, and more content is by default it's available in the assembly section. Once you go to the assembly section and if you wanted to place your spur gears and all this, you can place it. And other advantage is like not just placing the components from the library. So what you can do is you can analyze this. There is some rule-based calculation is also available. So for example, let's say if you are increasing the number of teeth of the gear, or if you are increasing the helical angle of your gear, so it will calculate and will tell you like what would be the force and what would be the torque of the gear. Okay. So these kind of a calculation also you get it from Inventor. Okay, it's not just creating a 3D model, you get a proper result out of it. Okay, so and also we do have a weldment is also available. Okay, if you want to provide some weldment, there are some different methods in weldment like spot weld, butt weld calculator, and field weld. Okay, so the different weldments can be supported here, and these are the kind of a dialog box which you can see within the assembly section, like shafts, spur gear, and all this. And once you're creating a spur gear or something, so it gives you the proper load and what is the loading force, journal speed, torque. Okay, and it gives you the error also. If your design is not properly created, and it will gives you the error in the red color. Okay, so that you can go back and recheck your design. Okay, so this is the kind of an advantage you get within the design accelerator. And since we are talking about the connected user interface, so as I said, like Inventor, maybe previously you might be using AutoCAD or different other softwares like 3D modeling tools like SolidWorks or Solid Edge or Siemens software or Creo. So it could be any different software it can be. If you have already some legacy data in Creo or SolidWorks, if you wanted to make use of it in your Inventor software, you can link those part models or an assembly. Okay, that's what we call in Inventor called enact functionality. So even if you look at this video, you get more clarity in how you can import the non-Inventor.
To design your products, you work with customers, suppliers, and manufacturers from all over the world, which means you likely need to use models in your designs that originated in CAD applications different from the one that you use. And while translation support and accuracy have certainly improved, when those non-native files change, the rework involved in re-importing and reapplying all the references and constraints made to the original file usually results in wasted time and effort. Autodesk Inventor changes the way you work with non-native data. With any CAD technology, instead of translating the file, you just open them using the reference option. You can insert parts or assemblies into your designs error-free while maintaining a link to the original file. But product design is an evolving process, and changes always happen even for supplied components. Typically, when a translated file is changed, the outdated version is replaced in the assembly, and any constraints, properties, and component references must be manually updated. With any CAD technology, when you receive the updated design files, the changes to the model are updated in a single click while preserving the work you've already completed. There are also situations where you need to make edits to the imported geometry directly inside of Inventor. For this, you can still accurately translate files from virtually any CAD system in use today, and then use the direct editing tool sets inside of Inventor to modify the designs of the imported components to meet the requirements of your design. Autodesk Inventor with any CAD technology and error-free file translation make it easier than ever for you to work with anyone, anywhere, regardless of what CAD system they're using.
Yeah, so you would have seen the advantage of using the AnyCAD functionality in terms of linking the other non-Autodesk Inventor products like SolidWorks or some other softwares you have been using it. Okay, if you have some data, like legacy data, you can import it. Okay, that's about this AutoCAD interoperability. I mean AnyCAD functionality. And AutoCAD interoperability is like to reuse your 2D drawings, because you might be working on AutoCAD for so many years and you might be having a lot of 2D drawings and which can be used as a reference of your 3D model. You can just link it into Inventor and you can start creating your 3D model out of it. And if there is any changes in AutoCAD and the 2D drawing, so again, if you come back to Inventor, so the 3D model also get updated. Okay, that's the kind of linking we have. Okay, it's not just we are not just importing the reference of the AutoCAD drawing, so we are reusing it. Okay, so it means we are using it, and on the design process, throughout the design process, if there is any changes in the AutoCAD drawing, it will get updated in the 3D model also. Okay, and also you can connect your electrical and mechanical designs also. And even I mentioned earlier, like you can use AutoCAD electrical to your cable and harness module also. Okay, if you create some schematic design in AutoCAD electrical, and you can just link that schematic design into one cable and harness, it will create a complete wire routing for you in Inventor. Yes, a kind of a 3D model in Inventor. Okay, so this is the kind of a quick functionality about your 2D plus 3D choice.
When you think of the move or transition from 2D to 3D, you may feel you have to choose between the two, leaving the comfort of what you know and how you've been working for years for a new and unfamiliar system. The reality is you can choose how fast or slow you want to transition. Moreover, since the user interfaces are similar, users can learn and transition at their own pace. The Product Design and Manufacturing collection allows you to leverage all of your existing AutoCAD data as you make the move to 3D with Inventor. Need your project to stay in 2D? Keep using AutoCAD the way you always have. Want to utilize some of your existing AutoCAD data to jumpstart your first 3D project in Inventor? AutoCAD and Inventor have an associative link that allows you to share data between the two of them. Reusing your AutoCAD data eliminates the need to start from scratch, allows you to control the pace of your transition, and ensures you will not have delays in your engineering process. Regardless of how you transition, most organizations still need a
kind of an update. Like you would have seen it in the video now, where he go back to AutoCAD and change the height of the bracket. So again, come back to Inventor, he refresh the design, so the 3D model also get refreshed, and same will be reflected throughout your entire design, even the part assembly and even in the documentation till the BOQ and part files. Okay, everywhere it will get reflected. So that's the kind of an integration available within AutoCAD and Inventor here. So the other area is around the BIM content. Let's say, for example, if you're working for if you're an EPC contractor, or if you're working for some of you, if you're creating a kind of an equipment for the buildings, okay, so you can create those components here and you can export it as a Revit family file, because in if you take any building projects, so many of our customers are using Autodesk Inventor. Autodesk Revit, okay, Revit application for architectural design and structure and MEP design. So if you want to create some equipments or some parts to be created in Inventor, you can create and you can export that as a BIM content to Revit software application also. Even that support is also available. Okay. Another thing is around the PCB interoperability. If you are working on some panel board or a switchboard, or the PCB designs, okay, you can do your integrated electronic works and mechanical works within the Inventor itself. And shared views is also available, like since we are on a cloud, and if you want to share your designs to the manufacturer team or to a marketing department or to a sales team or to other stakeholders, right, you can share your views, because while working on Inventor, you can invite the other team members. You can work in a kind of a cloud environment also. So once you share your views, so the other person, he can just have a link to open it on the Google Chrome, and so that he can explore the design, he can measure it, he can make some sections, and he can zoom in, orbit, he can check the properties, he can do a complete kind of a review. Okay, so that's the advantage of having the shared view. And the other advantage is like he can review the design and he can comment on it. Okay, if some material need to be changed, or some colors need to be changed, or some area is needs some improvement. Okay, any comments from the other side, he can add those comments on the design and he can send it back to you. So based on that, so the design team can update the changes. Okay. So more or less, like we have this data management also, like we might be working with mechanical engineer, industrial engineer, and multiple 2D draftmen will be working on it, right? And then it is proper one central location to collaborate the complete design. So within a proper firewall. So with Inventor, with PDMC, it comes with Vault Basic. So he can use some, he can do some Vault management, secure your designs properly we can provide some proper permissions in one central location. All other team members can properly integrate and collaborate their designs and make the data reuse. Okay, and you can monitor the complete revision history of your model elements. Okay, and also it comes with Autodesk Drive, which is a cloud storage. You can securely save your data on the cloud also, which is Autodesk Drive here. Further, which is like apart from Inventor, if you're looking at a PDMC collection, which is product design and manufacturing collection, we have other softwares like Nastron for analyzing nesting, factory design utilities, Vault Professionals. I think Vault Basic it comes in PDMC, and 3ds Max Navisworks for the coordination, AutoCAD. Okay, so we have other software tools within PDMC collection. So far I've been discussing with you only the Inventor Professional. Even in Inventor Professional, you can see like lot of features which is available, right? And the digital factory utilities, which comes in the part of an PDMC collection, which helps you to plan your factory layout. You can create your layout design. By default, there is a equipment libraries there. You can place those equipments from the library, and you can validate the complete layout, whether it is running properly or not. Okay, you can stimulate it, and even you can take this complete factory setup to Navisworks to review for the coordination purpose. Okay, how the conveyor belts are placed, how the equipments are moved in the conveyor, and how the spiral staircase. Okay, how the baggaging system can be created. So the kind of a complete factory warehouse setup or a factory planning, you can do it with the help of factory design utility. Okay, so that is a part of an PDMC collection. And with this, we have this fusion generative design, because right now we've been moving towards this additive manufacturing technology. Initially I told you, right, if you don't need to spend a lot of time in innovating your new concepts or new designs, you can just go to the generative design with the help of Fusion 360. You can create more different concepts. Let's say we have one of our key success story, like where they have used it for the seat belt system. You can see the seat belt with multiple brackets are there. Different parts need to be created, and then it has to be assembled, right? But what they did is like they have used the generative design so that there are 8 components, and they converted that 8 components into one single part. It means like one part there is no assembly, it's only one single part. But previously they used to have 8 different components. So with the help of generative design, they made us a one part with an innovative design. You can see it in the right hand side, and it is 40% lighter than the old one and 20% stronger. Even though you can see the difference is 40% it is lighter, okay, and now it's 20% stronger than the previous one. So that's the idea of using the generative design. Even you can see a quick example on this. Maybe you would have seen it earlier also. So there are 3 connections need to be done. So usually you would have seen this chases and all this, right? It comes with a kind of a normal design. But with the help of generative design, we are providing all the inputs like what is the pressure and parametric information, what kind of a strength I want. So we are providing all type of inputs to the system, and the system will make multiple iterations. You can see how many iterations are created here. It has like hundreds of options will be there. So out of 100 plus options, as per our inputs, you can pick. We have, for example, I have 5 options right now. So I can select. So I can check the strength, stiffness, mass, and what would be the cost of it. Okay, and manufacturing time and factor of safety. So I can check one of that and I can pick that. And even if you look at the design, it is like kind of a new design. It's like kind of a concept. It's not the normal one, it's a new conceptual design. And with the help of additive manufacturing technology, you can manufacture this component, right? This is how the manufacturing works. Even we have very good success in this. Even they have implemented this in the Volkswagen for the van. I'm not sure with the name of the van. So they have implemented on the Volkswagen company also. So, and also if you have any suggestions, if you're already using Inventor, and because we are open for feedbacks and suggestion, you can go to one of these pages like Inventor feedback community or Inventor idea page. You can share your ideas. So based on your idea, you can because we take inputs and feedbacks and suggestions from the customer, so that every year we release a product, so we add those options. Okay, if it is relevant and if it is feasible for us, so we will be adding those options, and we listen to your ideas and feedbacks also. So if you have any ideas that need to be incorporated within Inventor, you please go to this page and you can share your ideas with us. Okay. So this is what we discussed with you about the 3 pillars which I mentioned earlier: complete, automate, and connected. Okay, so Inventor has all this functionality, and it covers everything. Like if your electrical is also available, tube and piping is available, large assembly can be done, right, and automation can be done, sheet metal design, surface design. So there are many other features within Inventor. Okay. So I would say 1 hour is not sufficient for me to talk more about Inventor, because there are complete features out there. Okay. Yes. So any questions? If you have any questions, you can please unmute yourself and you can ask.